Let us learn about the right triangle in trigonometry in this video. First we are going to look at an isosceles right triangle and then a 30, 60, 90 right triangle. Now look at this isosceles right triangle. I call it isosceles right triangle because it is shown that the two short sides, two legs, measure the same and this angle is 90. As we all know, the sum of the angles of a triangle will be 180 degrees. Since this angle is 90, the other two acute angles together should make 90 degree. And so here, since the sides are equal, the legs are equal, the base angle should be equal. This angle should be equal to this. So this 90 degree I just divide by 2 and each angle would be given 45 degrees. Okay, so in isosceles right triangle the angle measures are 45, 45 and 90. Okay, now here let me take this this short side as x. Okay, so I take the short side as x. Since the other side is also equal to this one, this would also be x, right? You can find the third side, which is the hypotenuse side, using the Pythagorean formula. So you know that c square is equal to a square plus b square. So that is going to be x square plus x square. So when you add, you get 2x square. Your c square is 2x square. Therefore your c would be square root of 2x square. Since you don't have a perfect root for 2, I just keep it as it is. So I get root 2 and the square root of x square is x. So I get the c as root 2x. Okay, this one is root 2x. Now you see that the ratio of an isosceles right triangle is 1:1:root 2. So the ratio is 1:1:root 2 and the root 2 is your hypotenuse side. Now let's look at an example and see how we apply this property of a isosceles right triangle. Here in example 1, they have given you a triangle, an isosceles right triangle, and one side of it is mentioned. So we know since it is an isosceles right triangle, the other side would also be 5. You can use the Pythagorean theorem to find the third side, but this property of the special triangle, isosceles right triangle, helps us to find out in matter of seconds. Okay, we know that the hypotenuse side is always root 2 times x, right? And here the x is 5. So the third side here would be, hypotenuse side would be root 2x, right? So the x is 5. So you get it as 5 root 2. The answer is 5 root 2. As simple as that. The third side you can find using the property of a isosceles right triangle. Okay. Now look at this example here. Example 2. Here, instead of the shortest side, the short sides, legs, the hypotenuse side is given. So this is easy. We know this side is root 2x, right? And here you have to get x. So you know that root 2x is equal to, the hypotenuse side is equal to 18. So your x would be, just do the opposite. You are dividing throughout by root 2. So you get 18 over root 2. We normally don't stop a fraction with a third as denominator. So rationalize it. You just need to multiply the numerator and the denominator by the same root 2. And so you get 18 root 2 over 2. Root 2 times root 2 is 2. Okay. Now you can cancel the 18 and the 2. And this is going to be 9. So you get your x as 9 root 2. Okay, as simple as that, 9 root 2. So here the two sides, short sides are 9 root 2 and 9 root 2. Did you get that? So this is all about the isosceles right triangle. Now let's look at the second special triangle, that is a 30, 60, 90 degree triangle. Here I have given you the picture of such a triangle. The angle opposite to the longest side would be 90 degrees. Since that is the longest measure you have, and always the longest angle would have the longest side, and this is the shortest side, right? So the angle opposite to this would be shortest one. So I take this as 30 degree. And here the long leg would have the next measure, which is 60. So this is a 30, 60, 90 degree right triangle. Now let's look at the ratios of their sides. Here again the shortest side I take it as x. Okay. So as per the property, the longest side would be twice the shortest side. So that would be 2x. And the third side, of course, you can find using the Pythagorean formula. So that is going to be b square is equal to c square minus a square, right? This c square is 2x the whole square, and your a square is minus x square, right? So that's going to be 4x square minus x square. So this is 3x square. Okay, 4x square minus 1x square is 3x square. So your b square is 3x square, and hence your b would be square root of 3x square. So that will give you, since you don't have a perfect root for root 3, I just keep it as root 3, and the x square, the square root would give you x. So your b is root 3x. So this side would be root 3x. Okay. And now the ratio here is 1 is to root 3 is to 2. Okay. Now let's see how we apply this property in the problems. I have given you an example 1 here. Look at the example 1. So here this is the shortest side. So this angle should have been 30 degree, and this is the long leg. So this is 60 degree, and okay, the other one you know already know. Now you know the ratio here, right? This is x, and here it is 2x. The hypotenuse side is 2x, double the short side, and here this is root 3x. Just substitute the x values here to get the other sides. Okay, so your hypotenuse side would be 2x. So that is 2 times 8, which is 60. So you got this side as 16. So simple. This is 16 here. Okay. Now the long leg, root 3 times x, right? So that is root 3 times x. Your x is 8 here. So your answer is 8 root 3. 8 root 3. Okay. Now the second example, wherein the hypotenuse side is given. So as soon as you get these triangles, just figure out the ratios, where to put the ratios. Okay. Since this is the shortest side, this should have been 30 degree, and this is the longest leg, so this would be 60 degree, right? Now let's fill in the ratios. So your shortest side is x, your hypotenuse side is 2x, and the long leg is root 3x. Now you know 2x is equal to, it's given 2x is equal to 36, right? So you can find out the x by dividing both sides by 2. So that's 18. You got the shortest side now. This is equal to 18. Now for the long leg, you know that it is root 3x. So that is going to be root 3 times your x is 18. So that would be 18 root 3. So this side is 18 root 3. Okay? As easy as that. Now the last example 3 in the 30, 60, 90 degree angles. Again, let me complete the angles. The shortest side would have 30 degree opposite to it, and the long leg will have 60-degree opposite to it. Immediately fill in the ratios. This is x, this is root 3x, and the longest side is 2x. Okay, so here you have got root 3x equals 24, right? So let's find what is x. So dividing throughout by root 3, you get 24 over root 3. Since it is a third, I am multiplying the numerator, I am rationalizing it. Root 3 over root 3. So that's going to be 24 root 3 over 3. You can cancel this. So you get 8 root 3. Your x is equal to 8 root 3. Okay. Now that you're done with the short side, you got it as 8 root 3. The hypotenuse side is 2x, twice the short side, right? So that is going to be 2 times 8 root 3. That is 16 root 3. So your hypotenuse side is 16 root 3. So this is going to be 16 root 3. And that is all. So we have done. So to sum up, for the special right triangles, like an isosceles right triangle, you have 45 degree angles for the acute angles, and now the ratio of the sides is, if this is x, this is also x, and here it is root 2x. So the ratio is 1 is to root 2. Here again, the 30 degree angle, for this 30, 60, 90 degree angle, the 30 degree angle will have x as its opposite side, and the hypotenuse side is root 2x, and this long leg would be root 3x, making the ratio as 1 is to root 3 is to 2. Hope this video would have been helpful to you. Thank you. Bye.